Hi everyone. So I'm doing a little work at home right now when Molly goes to bed. So these are notes on applications of uh, parallel and perpendicular lines, and they're going to show you how to apply them. So the first step is when we're actually writing equations of lines. So is always to identify what is the question asking me. Okay, and in this question it's asking me to write the line parallel to, and parallel always has the same slope. So parallel, and it's parallel to that graph right there, and it passes through the negative 1, 6. So first thing I identify is my slope, m equals 2. So then I can take that and I can plug that in to y equals mx plus b. Then I take the point I'm given, x and y, and I plug that in just like I did in the previous example. So I get 6 equals 2x times negative 1 plus b. I then solve for b. I add 2 on both sides. So my b is 8. Now I just rewrite the equation. Y equals 2x plus 8. What I want you to notice, okay, is that this 8, this y-intercept here, is different than that 12. Because parallel lines have the same slope, but they have different y-intercepts, because one is going to be like higher and one's going to be lower. They never intersect. They're going to rise and run the same, but they're going to have different y-intercepts. Alright, so here's a demonstration of this. So you're going to find the equation parallel to that line. So the first step is the slope, okay, up 1 over 1, okay, and it's going to go through that point, 5, 1. So I just continue, up 1 over 1, up 1 over 1, and I start drawing that line. And you can see that that red line is going to be above the line that I'm given. So now I can write the equation, y equals 1x, or just x, and then I just find the y-intercept where it's going to cross, and that's going to cross at negative 5, or negative 4. So that is my equation. Perpendicular lines are a little bit different. Again, opposite reciprocals or negative reciprocals. Okay. Technical error there. So I'm given this equation in standard form, they call it. So what I have to do is I have to convert it to y equals mx plus b, slope-intercept form. So I have to solve for y. So I'm going to rewrite this equation, and then I'm basically just going to move around those variables. So I'm going to move this 2x to the other side because I'm solving for y. So I need to get everything away from y. The negative 3y is left. I'm going to write minus 2x, or negative 2x plus 9. And then I'm going to divide by negative 3 to everything to get y alone. And I'm going to be left with y equals negative divided by negative is a positive 2/3 x, and then 9 divided by negative 3 is negative 3. So my m for that is 2/3, my slope. And that's what I'm looking for, because now I have to do the negative reciprocals. So I'm going to flip that and change it from a positive to a negative. Okay, so my m that I'm looking for is negative 3 over 2. And now I can just take that and follow the same steps I did. 3 over 2, x plus b. I then plug in those points. Okay. I get 2 equals negative 3 over 2 times negative 4 plus b. Now again, people don't like multiplying fractions. You just multiply the 4 and the 3, the negative 4 and the negative 3. I get 12 over 2. I can then divide that and then subtract 6 on both sides. I got b is negative 4. So now I can rewrite the equation. Y equals negative 3 over 2 x minus 4. And that is my answer. Now, the other application of this is actually geometric. So it's proving something is a parallelogram. A parallelogram, you might think of as a slanted rectangle, but the definition is that it has two sets of parallel sides. So what you have to do is you have these 4 points, and all you do is you find the slope between all the pairs. So I'm going to find the slope between AB, I'm going to find the slope between BC, I'm going to find the slope between C and D, and then D and A. So I write it as AB. So between A and B, I'm just going to do the slope formula. And you got to remember that 3 minus -2 comes out to be a positive 5. Do B is C. Now those are not parallel because they're not the same. But you'll see when I do C to D, I'm going to do, and that double negative again, 0 minus -1 is going to be 1 over -5. Okay? Do you see that negative 1 over 5 and that 1 over -5? They're the same slope. And when I do D to A, you'll notice that it comes up as, it's going to end up being 3. And also you have to watch out for your negatives again. So notice that BC and DA or AD, those are the same. And AB and CD, they have the same slope. So do they have 2 sets of parallel sides? Yes. So therefore, it's a parallelogram. And I can graph it and see. Now the second part is when I'm proving something's a rectangle. You might notice rectangles, they'll always have that 90 degrees in the corners. That 90 degrees means that each side is perpendicular to each other. Perpendicular, opposite reciprocal slopes. So I'm going to do the same steps as I did with proving a parallelogram, only now I'm going to do it and prove that's a rectangle. So again, I pair off the sides and or points, and then I find the slope. So 3 over 1 or 3. B to C. Now, this comes out to be -2/6, which I have to reduce down. But you notice when I reduce down, so you notice that when it becomes -2 over 6, which I reduce down to -1/3. And right there, you notice that they're opposite reciprocals. So now I'm just going to repeat the same process for the other 2 sides, and I'm going to check if they come out to be perpendicular or not. And what you'll notice is AB and CD will also be the same, okay, and DA and BC will be the same, because a rectangle is technically a parallelogram. It's a type of parallelogram. So a rectangle fits the definition. It just has that extra piece that there are 90-degree angles in the corners. But all I'm really concerned about is that opposite reciprocal. So you see those are opposite reciprocals. Okay, and each pair is actually an opposite reciprocal of each other because they're both the same. So this is a rectangle. And you'll also find that those will always be the same, and C to D and A to B will be the same. And we can plot it and check it out.